This is Global Ummah Unity, faith, history, and truth in one voice. Muslim Astronomy: How Islam Mapped the Stars Before NASA. When we think of space exploration today, we often think of NASA, astronauts, and high-tech telescopes. But long before rockets reached the sky, and centuries before modern observatories were built in the West, Muslim scholars were already mapping the stars, with stunning accuracy and deep insight. This is the story of a scientific legacy hidden from most textbooks, a legacy that changed the way we see the universe. Let's go back to the 8th century, during the Islamic Golden Age. In the heart of Baghdad stood the House of Wisdom, a place where scholars from many cultures came together to translate, preserve, and expand upon the knowledge of the ancient world. Among their many passions was astronomy, not just for religious practice, but as a pathway to truth and understanding. For Muslims, the stars were not just lights in the sky. They were signs, tools, and a source of wonder. The early Muslim world developed astronomical instruments far ahead of their time. The astrolabe, for example, a complex device that could calculate time, track the position of stars, and help navigate the land and sea, was refined and perfected by Muslim engineers like Al-Fazari and Al-Zarqali. But Muslim contributions went far beyond tools. In the 10th century, the Persian astronomer Al-Sufi wrote the Book of Fixed Stars, correcting errors in Ptolemy's ancient catalog and providing the first recorded description of what we now call the Andromeda Galaxy, 1,000 years before it was acknowledged in the West. Muslim astronomers named and charted stars with a precision that would not be matched in Europe for hundreds of years. And the names they gave, Altair, Vega, Betelgeuse, Rigel, are still used today in international astronomy. In fact, most of the stars officially recognized today by the International Astronomical Union bear Arabic names. Muslim astronomy wasn't just about naming, it was about measurement. In the 13th century, Nasr al-Din al-Tusi built the Moraga Observatory, complete with large-scale instruments, a rotating dome, and a mathematical system that would later influence Copernicus. His model, the Tusi couple, showed how linear motion could be derived from circular motions, an idea that would reappear in the work of European scientists centuries later. Later, in Samarkand, Ulu Beg, a prince and mathematician, built one of the world's largest observatories. With a massive sextant, he compiled a star catalog of over 1,000 stars, more accurate than any before him. While Europe was just beginning to break free from centuries of intellectual darkness, the Islamic world had already mapped the night sky. Through Muslim Spain, this knowledge flowed into Europe. In places like Toledo and Cordoba, Arabic texts were translated into Latin. These works directly shaped the scientific awakening of the West, though their origins were often forgotten or ignored. Even as the Renaissance celebrated men like Galileo and Copernicus, few acknowledged the shoulders they stood upon, scholars of Islam, whose observations, charts, and theories had made their discoveries possible. Today, when we look at the sky through NASA's telescopes, we use coordinates and systems that trace their roots back to the Islamic Golden Age. Modern astronomy as we know it is not just a Western achievement. It's a global inheritance, and the Islamic world played a central role. The stars have always inspired humanity. But it was the Muslim astronomers who first truly measured them, named them, and understood them, not just through faith, but through reason, precision, and deep curiosity. This is not just a chapter in Muslim history. It is a chapter in human history, and one that deserves to be remembered. Because before NASA, before satellites, before telescopes, there was Islam. And Islam mapped the stars.
Let's now go even deeper into the very foundations that made Islamic astronomy so far ahead of its time. At the heart of it was method. Muslim scholars didn't just observe, they measured, recorded, corrected, and verified. They believed that knowledge should serve both faith and humanity. That's why astronomy flourished, because it was not only useful in daily life, but also seen as a way to appreciate the order and beauty of God's creation. Unlike many societies at the time, the Islamic world encouraged questioning, debate, and innovation. Scholars were not afraid to challenge earlier Greek models if they didn't match reality. One such revolutionary was Ibn al-Haytham, also known as Al-Hazan, often called the father of optics. Though he is best known for his contributions to physics and vision, his approach to scientific experimentation laid the groundwork for a more empirical method that influenced astronomy directly. He taught that truth can only be reached through observation, not authority, a lesson that would later echo in the works of Galileo and Newton. But Al-Hazan lived 600 years before Galileo. And this reveals something profound. The Islamic scientific spirit was already moving toward what we now call the scientific method, long before it became the norm in the West. Now let's look at the observatories again, not just buildings, but centers of international collaboration. At Moraga Observatory, scholars from across the Islamic world, Persians, Turks, Arabs, worked together on celestial measurements. They developed detailed planetary models that sought to fix flaws in Ptolemy's system, which Europe still relied on at the time. In fact, the famous Copernican revolution may have had direct roots in Moraga. Recent studies suggest that Copernicus's models show mathematical similarities to the ones created at Moraga, especially the Tusi couple and Urdi's lemma. Did Copernicus read Islamic sources? We can't say for sure, but many of those works had already been translated into Latin by then, so the influence is highly likely. Meanwhile, in Samarkand, Ulugh Beg not only measured the length of the sidereal year, the time it takes Earth to orbit the Sun relative to the stars, with incredible precision, but he also trained generations of astronomers. His school continued refining astronomical tables used throughout Central Asia and even India. His star catalog, completed in the 15th century, remained one of the most accurate in the world until the advent of modern telescopes. Let that sink in. With no electricity, no satellites, and no advanced optics, Muslim scholars were producing data that would remain unmatched for centuries. What's more, astronomy was integrated into education, architecture, and art. Mosques were built using precise calculations of the Qibla, the direction to Mecca, based on star positions. Sundials, astrolabes, and water clocks were used not only in science, but also in worship and urban planning. In Cairo, Damascus, and Istanbul, mosques and madrasas became centers for astronomical research. The minarets themselves sometimes functioned as observatories. This wasn't science kept in ivory towers, it was living knowledge embedded in the daily lives of millions. And it wasn't limited to men. There are records of Muslim women in the Abbasid and Fatimid periods who studied astronomy, philosophy, and mathematics, often under the guidance of their fathers or in advanced households of learning. This inclusive, dynamic culture of knowledge is rarely acknowledged in modern narratives of science history. So what happened? Why did this incredible momentum slow down? There were many factors: political instability, invasions like the Mongols in the 13th century, colonial disruption, and later economic stagnation. Meanwhile, Europe, having absorbed Muslim knowledge, began its own scientific rise. Over time, the sources were used, but not credited. Books were translated, ideas adopted, but names like al-Sufi, al-Zarqali, and al-Tusi were slowly erased from public memory in Europe. The irony? Modern space science, including the systems used by NASA, still relies on principles developed during the Islamic Golden Age: spherical trigonometry, celestial coordinate systems, and star cataloging methods. But in school books, Islamic astronomy is often mentioned in passing, if at all. And that's why this story matters. Because history isn't just about who did what first. It's about recognizing that human progress is collective, that the journey to the stars began not in one place, but through a network of civilizations, learning from one another.
Thanks so much for watching this video on Global Ummah Unity. If you learned something new today, don't forget to like, share, and subscribe. Let's keep uncovering the untold stories of the Islamic world. Together. See you in the next one, inshallah.